as a professional video that you put out,
Oh,
well
thanks.
spoken. Yep, you got kind of a lawyer like approach. I, I agree with maybe 40% of it. Um, but but here's a problem that I really have with that is, you could see similar traits, similar features in animals. Even the ones you seen, it were pretty, like some were convincing. Like you saw, like one of those appeared to have some type of almost like frog legs or something like that.
Mm-hmm.
But the problem is this here. Um, as far as so I'm assuming that your belief is at least 80% of evolution would have to be from mutation and natural acting on random selection, acting on mutation. Um, is that a correct assessment?
Yeah, I'd say at least 80, if not
Okay,
all of it.
good. At least 80. Great, beautiful. I love it. I love it. Okay, so the problem is um, to me, evolution is reductive. And you can get some variation, but it's mostly reductive. That's like a football team that went 3-13. You had a couple of wins, but for the most part, you had more losses. I look at evolution as having more losses than wins, way more losses than wins.
Well, if I would guess that it's probably easier to evolve features that involve losses because naturally it's just more likely. But
It's you
but
say, wait, wait,
for
it's easier.
example, like snakes losing legs or whales losing legs or losing hair is still a change in body type, right?
True, but at the same time, though, it gets to the point to where, you losing more than you're gaining, but yet what you have to do is you have to come from. Let's just assume, and this won't be the argument, but let's assume that you're able to get to a cell. Okay, let's start from a cell. Okay, now from a cell, you have to gain. You got to really increase. So you got to do a lot of more increasing than you got to be doing increasing. And see, here's the thing: the examples that you really gave us, that you really showed, were really good examples, and it really show quite a bit of variation. And like the paper you cited, when you said there are more variation in between species than out of species or whatever.
Yeah,
Is that how you said it? Okay,
yeah.
exactly.
There was
But you know what?
more variation of like vertebrae, but within the same species than between bat species.
Okay, okay, beautiful. Here's a problem with all that. That basically speaks to creation, really, honestly, because other thing is that if evolution is reductive, if you lose a lot of information to gain information, therefore that you would have to go over to Jensen's created heterozygosity theory, that God created these creatures with a high level of heterozygosity, where you had the ability to get all these different species, creatures, and features, and some of these features were turned off. Okay, and then when the environment needed it to be, they turn on. We see that with humans. Like, prime example, say if you lived in a low altitude area and then you move to a high altitude area, your body will adapt. Say, for example, if you was used to eating a certain amounts of food and you had to go to a more restricted diet, your body's metabolism will slow down. That's called homostasis.
But
You know this already.
that's not even genetic. That's just built into the system that it has different feedback loops. So it you don't have to change your genes. The system already is plastic by itself.
You don't have to change the genes, but you have to change where the genes are expressed. That's
Um,
another level of complexity there.
Not necessarily.
Okay, what could be the groundwork? What could be the grounding for it then? It has to have some kind of grounding.
So like if you get sick and your body starts giving you a fever or producing more mucus, that's not a genetic change. It's your cells communicating with each other using hormones usually.
Okay, so that's what it's rooted in then. So it's rooted in hormones, but it's rooted in a system. Okay, all
Yeah,
this points back to that.
and what?
All this points back to a system.
Yeah. So I don't know. I feel like we're kind of getting off on that topic. So there's not really any evidence of created heterozygosity for those traits.
Why
Um,
wouldn't it be?
well,
Okay, so
you'd
okay,
need to show that they already had those genes
o-
just kind of
okay,
unlocked or locked away.
but we see that all the time, though. We see genes being. We see more. Okay, listen. We see more
There are cases of
rapid.
that
Hold on.
like that.
We see more rapid evolution than slow evolution. Then we have evidence of slow evolution, right? What is this rapid evolution? Epigenetic responses to the environment changes. The Italian lizard, it changed its diet. It developed these cecal glands, and then when it changed back, they lost the cecal glands.
That does
That's
happen.
a system. That's a system, right?
Right, that
Evolution
does.
don't build evolution don't build systems.
Well, it can.
How,
Uh, the
what
Lenski
would be its
experiments
criteria?
showed that.
What would be evolution's criteria for building systems?
What do you mean? What is the criteria for building
Yeah,
systems?
yeah. Why would it
Like, how
even?
would we know if it happened?
Nope. Um, it's kind of a cause and effect thing. When you build a system, to me that's a purposeful thing. A system operates on algorithms, it operates on environmental conditions, it operates on needs and wants and survival mechanisms. So a system is just something that just automatically just pops up. It's something that's incorporated, inside of species and creatures. So how do you get to that? Through blind processes. And the thing about it, I tip my hat to you because you're not one of those watered down evolutionists who jump ship. You get a position and you stick with it. If you get convinced in a different direction, okay, whatever. But you're not like, real slippery like T Jump. He's very slippery, where he'll just his argument changes. He just try to figure out what you're trying to say and then try to find little funny things to say. He never want to commit himself. You're very committed,
Well, I
which
think
is
he's
good.
more broad strokes kind of thing too, because he doesn't
No,
know
he's
the
garbage.
specific
He's he's
science.
garbage, man. He's garbage. He's garbage. He's you see that debate when he debated the one creationist, I can't think of his name, just recently, and even the evolutionist was dogging him. He was calling this guy a dumbass and all this kind of stuff during the debate. He was just so disrespectful. The one time he did a debate, and I'm pretty sure you've seen it, he uses Jackson's Wheat's complete argument, complete video while he was eating pizza.
Yeah,
Come on, man. He's garbage, pure garbage.
that was funny.
So
Um, so what you're describing about certain genes turning on when they need to that are unlocked based on environments, that does happen. However, the actual change of genes also happens. So we can tell with features like the baleen in whales is it's not a secondary gene. It's not a heterozygous gene. It is literally the same gene as in toothed whales, like dolphins, with some of it's called a pseudogene. So basically,
Yeah,
um,
it's missing some nucleotides.
it's missing some. But so you might say, well, that's like de-evolution. But the problem is that losing some of those nucleotides means now it has
Another
a
feature.
different information, at least. I don't know
Right.
if you would qualify it as more, but baleen is definitely functional information
But that
and a
wasn't really.
functional anatomical
But those
part.
genes, hold on. But that particular gene you're talking about, that was a gene that encoded for enamel. It wasn't the gene that encoded for a baleen. And then there was a team of scientists basically actually look at those genes, and those particular genes, which was these Hox genes. They use those same genes inside of. They look at those same genes inside of, I think it was mouse or chicken or something like that, and then they wasn't expressing in the same location because they put those broken genes, those the genes that was missing some nucleotides. They put those genes in where they was thought that those genes were controlling the hind limbs, and, and they lost those genes. They lost the hind limbs because it was missing those nucleotides, and so they put those same genes inside of I don't know if it was a chicken or something like that. Then they found out those genes was not even being expressed in the same location. So you can have the same gene. Here's the thing with genes. Genes are so tricky. You can have a gene for one thing that can code for so many different things, okay? And
Yeah,
then it can
and
also.
but that's how systems build in evolution is that there are redundancies and there are multiple functionalities. So they can mix and match with other traits in interesting ways, which can build systems. And chemicals are like that. They have cycles and they have loops that can interact with each other.
Right, but you can say that though, but you can also say we can also say that redundancy is a creative feature because that redundancy is backup mechanisms. And also the redundancy that you see sometimes has a lot to do with, you know, temporal based controls. Sometimes for a gene to fold correctly, okay, you need more nucleotides because when these nucleotides actually go into the ribosome, the more nucleotides you have, you know, it actually contributes to translational pausing. This transitional pausing makes that gene fold differently so it can interact with the environment. Also, it allows when you got the wrapping of the genes on the histones, the locality of the genes and the positioning makes it easier for it to communicate with other genes on the other genes that's on the histones. So, when they start finding out those features, the redundancy in evolution, you can make an argument for both. You can certainly use that redundancy for evolution, but it seems like it make more sense when you find purpose in that redundancy.
Well, you can make creation fit pretty much any story because a god can create anything, right? But
You could
that's
put both ways.
but that's not scientific of just fitting trying to come up with an explanation and trying to fit the data to it. What's science is when the
Let's be fair. Let's
hypothesis
be fair. It's
can
both ways. You start with a hypothesis and a thought, right? And then you find ways for it to fit. It's it's 50-50.
Well, no, because actually scientists try and make the hypothesis not fit. That's the test.
Well,
So,
okay, so
so what they're doing is
not
trying to
necessarily.
predict the
That's not
data.
true. Hold on. That's not true. Let's be honest. That's not true. They have to do that for the paper or the scientific theory to be plausible. They're really not trying to falsify it. They're trying to prove that it could be falsified.
Well,
Okay,
the person who
let's
writes
be
the
honest.
paper usually is trying to prove their pet theory, but the peer review process is other scientists looking at that, and usually they're trying to find faults in it because they're actually competitors.
Okay, okay, and I can agree with that to a certain extent to that one. They will try to find faults, but see, a lot of it, it really kind of depends. It depends on the actual competitors because you may have a scientist that may really focus on a different part of evolution or a different type of science. He may believe in evolution. This guy is going to agree with you because it's going to fit the paradigm, but it may be a contender, especially when you're talking about like human evolution. It might be a contender that's going to try to make you wrong because they want their hominid or whoever to be at the forefront. So they're going to try to prove yours wrong. So it really depends on who you're talking to. But for the most part, if an evolutionary argument or position doesn't affect a particular science and that particular field that he's dealing with, he's on board with yours because they want to push the evolutionary paradigm the same way creationists want to push theirs. Let's be honest. There's bias on both sides of the court.
Well, there of course there's bias because evolution is already accepted by the entire scientific community. So they
No,
take it as a given. They're
okay,
they're
so
really not like a lot of scientists don't even realize creationists are still around.
well, see, that's again, those are pretty broad strokes, my man. Those are pretty broad strokes. It
Well, we're talking
really,
about
it really. Okay,
trends
so
in scientific publishing, but so if we're talking about, if we're doing the same thing, it really matters in science which theory predicts the data better. So, like we were talking about last time, there are some errors in the theory,
come on, baby.
and um, sometimes predictions go wrong, and that's
A
expected in
lot,
science.
a lot.
Yeah,
But see,
but
let
but what
me ask you a
matters
question.
is
Let me ask you a question.
is it better at predicting than the alternative? And the answer is still yes. Because
No, it's
if it
not
was
because
perfect all the time, then science would be solved.
listen, it's not. Here's the thing. Bad predictions don't get talked about. Predictions that appear to be correct, you throw parades for it. And then you got to pull it back to parade because it turned out to be false. That's how it
Yeah,
works.
and then we adjust the model
But see,
and
that's
proceed. And usually, after the adjustments are made, then we start making even better predictions.
but see, that's like honestly, that's just like that's like the. I mean,
But
that's kind of
it's
like
about which has more successes. Is
but you know what it sounds.
how many fossils have
You know
been
what it sound
found
like,
from
right?
creationist principles?
But let me tell you what that sounds like. That sounds like you at a trial, you've been found guilty, right? And then you had this concession speech. Well, he did this in the community and this and that. He understands his wrong and this and that and all this. You try to butter it up, but what it really is we over celebrated about her prediction. Then we found out that we was wrong. So now we're gonna take this glorious high road by saying, well, science corrects its mistakes. No, you celebrate it, and it was way too early.
But the same
That's
thing
what that's
happens
the
in
real end of the
physics.
story.
But we don't
Uh,
just throw out the whole physics book.
look, no. Okay, so you shouldn't throw out the let me be the first one to say the the theory of evolution does not really have to be thrown out. It just has to it just have to be understand that there's limiting factors on it. That's what it boils down to. And we need a universal, clear
Well,
definition.
there are limiting factors. I mean, the most
Yeah.
obvious one is it's limited to the traits of the parents.
No, it's more limited than what they say, than what is way more limited than that.
Well, it's
Uh,
limited by the laws of physics
it's,
and chemistry,
it's
but
boundaries. It's no. There's complete. There was a paper. I think that same paper. And then I'm Speckle Thorn Speckle something like that. Basically found that there was limitations. There's
yeah, of course there are.
right, and there's limitations on how much a protein can fold,
Yeah,
because if a protein try to fold too far past the projected shape, the chaperone protein chops it up for food. Why is it? Why is there chaperone proteins if evolution is allowed to do anything it wants to do? Why would it be chaperone proteins there? Because it has a protein has a intended target, right? And if it fall past the intended target, it gets messed up. Now the variation is if you may get some, you may have a copying, of a transcript or whatever, and it may overread it a little bit, and it may add a few nucleotides on the end of it. That may have an effect on the regulatory factors, and that may create some variation, some lengthening, some shortening, or something like that. You may get a little bit more variation from that. But that was after the protein, the looking for the quiet words I need. You need for it to hit, you need for it to, it's got to be way downstream. When you have mutations early in the stream, that's going to change the whole fold. Then you're going to have deformities. You're going to have problems. You can't have mutations early in the stream. It's got to be downstream, right? Do you agree with that?
it just depends. There's some wiggle room.
Okay, so I think it's very, very rare that you can have a protein. You can have, okay, so would you agree that uh, that when the RNA polymerase reads a segment of protein, a segment of nucleotides, and then you get that stop codon in there, and it stops reading that one. That there is an intended target on what that protein is supposed to do. Would you agree with that?
Yeah, but that's why most evolutionary changes are pretty. They're not really huge. It's once you have animals, everything's already there. Like most of the um, really complex molecular stages are already working on the cellular level.
Okay. My
So like
problem is
a tetrapod already has most of the genes that are going to be needed for mammals, and mammals
yes.
all have most of the same genes.
Well,
So there's not
that's
going to be
that,
that much of an actual. It's more of a regulatory changes mostly.
well. See, here's the thing. Here's the thing. When you're talking about, okay, let's talk about the bats. Was it the bats? Okay.
Mm-hmm.
Um, you made some really good points. Like I said, I really enjoyed your video. You know,
Thanks.
um,
And that was
and
just
you
part
made
4.
right. Well, you made the point. You made the point about the bats, and that we don't have any. There's no bad evolution, right? And but I
Well, I
think
made the point that there is bad evolution.
that we say that there's no bad evolution,
Yeah.
right?
Yeah.
But that's not what we really say.
Well,
We say that we
it
don't have
depends.
any
It was it was very specific. Someone told me that there is absolutely no bad evolution,
no, we say that
which was the
that
inspiration for that. Um,
right, but what we say is we say that we don't really have any we don't have direct ancestors of bats. We don't have anything that's turned into bats or come out of bats. And what you did was you showed quite a bit of variation in bats, and then you showed creatures that was kind of similar to bats. But the thing about it is we accept that. I accept.
yeah.
I I accept you're going to get variations. Let me ask you a question.
But
Uh,
the point. Okay,
hold
go ahead.
on. Before you say, let me ask you a question. Okay, beside gene combination, okay, mutation, isolation, what other factors do you contribute to evolution that brings upon the diversity beside those factors? What else do you use? Epigenetic regulation. What other factors do you contribute to evolution to be able to create diversity?
Um, there are social or altruistic traits.
Those are what?
What social or altruistic traits?
Oh, is that a mechanism?
Um, sort of. Do you
But
mean like a molecular mechanism? No.
I think that falls under. I think that's kind of a real more of a subtle thing. I'm talking about, if you want to involve a substantially different creature into another creature, right? You mainly talk about mutations. Um, uh,
But my
what
point
you consider
wasn't necessarily about mechanism. It's about what is accepted. So the accepted amount of variation already covers the gaps in the fossil record. So the amount of variation within bats that is accepted to happen in adaptation is enough to explain the differences between bats and non-bats. Like the difference between a shrew and a bat.
well, I'm
Because
talking about. Go ahead.
all it would take is variation to the length of bones and density of muscle, which is already accepted to be possible.
Okay, so let me ask you a question then. So again, how does that go against um, you know, um when the homozygosity method of creation that the genomes had more genetic uh traits that they can absolutely draw from, and they had more ability to create different kinds. How does that go against it?
Well, heterozygosity is actually having another copy or another
Yeah,
variant of a gene
right.
at the same time as the other one. So it's not a case of a different gene activating, it's that the old gene is replaced. There aren't two versions. There's just one
But
version that's
okay,
different.
but when it get replaced is when you start getting to specific species and specific creatures. But before then, you have those genes. You got more genes, and then as things evolve, they actually lose genes, and then that's when they started to nest down into the particular kinds. And then what they do is they recombinate with other genes, and then you get a little bit more variation from there.
But if it's
But for
part
the
of
most
the
part,
design to be able to have this, to be able to genetically switch between different variants that would cause like huge morphological changes, then why is oftentimes the original gene always being lost?
I mean, it could
Why
get
doesn't
lost
it retain that one?
it can get lost through complete isolation. You get so many different recombinations, it becomes very recessive.
But
And that's the
I'm just
difference.
struggling to understand why. So the creature is around for hundreds or thousands of years, and it keeps its variant in its back pocket. But as soon as it switches to that variant, it loses its original gene.
I don't
That's
know if it,
that's what would have to be
I don't know.
happening in a
I don't
majority of
know.
these
No,
cases.
I don't think it. Why do we got to lose the why do why can't why can't that just be the gene frequency, you know, being expressed most of the time? Why does it have to lose that original gene?
Yeah, that's the question.
No, no.
Why
Why
would
does
it?
it?
If it's not losing its variant that it
It
keeps in its
probably
back
didn't,
pocket, then why is it losing the original one?
but it don't have to lose the. I don't know if. How do you going to prove that it is losing the original gene?
If
It's it,
there's
it's
well,
losing some. It's losing some.
heterozygosity is having two variants.
Right. But what I'm saying is losing some. But according to hold on, according to Jensen, it could have more than two variants. It could have a wide variety of variants, right? Why do we got to have just two?
I'm just not aware of any cases where that has actually been
Okay,
confirmed.
okay. So in that case, mutations they're losing variants. When you have mutations and you get isolation, right? You lose variance the same way you lose quite a bit of variance when you go from a wolf to a poodle. You losing a gang of variance. Now you can recombinate a poodle with a Saint Bernard you can bring the variance back up again,
So
right?
there's two spots on the chromosome because you have like two copies, one from each
Right.
parent in the whole chromosome. So you'd have one variant of each part of that. So with created heterozygosity, you'd have to have it the same. You'd have to have a gene variant at a different place in the genome.
Okay. Why can't you
So
have it? I mean,
there'd have to be a mechanism to know to tie those two together, so that
well, it
if
would be
one turns off, the other activates. Um,
okay. Well, you guys believe that that happened. You guys believe that that's the same thing happened with the human chromosome fusion when it would have been two centromeres, and then one got deactivated. But I don't know if it necessarily has to be that. It can just be that the one lay dormant. Why can't it just be that one just became dormant? That when you have so many um, variations and so many gene combinations that those genes that recombinated, the recessive became the dominant, and the other one just kind of just sit back because you keep on mixing poodles, you keep on mixing dogs like that. You no longer, you may still have that wolf variant in there, but it's so recessive that it just don't come to fruition. I mean, what's wrong with that?
well, dominance and recessive is more just about. It's not really genetic. It's not
It's
programmed
numbers.
into the genes. It's basically whichever one chemically trumps the other.
Okay. Well, see, what do you mean by chemically trumps the other?
So, if there's some sort of pigment that I don't know, like a gray pigment, that would be recessive because if the pink pigment is present at all, it's going to appear pink. So you could have one copy of pink and it appears pink, or you can have two copies of gray and it's gonna appear gray. So It just
Right.
depends on what the trait is. It's not really in the gene whether it's dominant or recessive. You can't really. It's not like a switch you can flip.
Okay, so what happens? So let me ask you a question. Let's look at that in perspective to um, a parent, a parent and a parent from a mother, where you know through their ancestry they had brown eyes that was really dominant, but then they had some blue eyes in there, you know, right? And then you have a situation where you have the father almost had the same thing. You have mostly brown eyes, but there's some blue eyes in there where different relatives have blue eyes. So you're still carrying that brown and blue variant, right? But except the brown is showing up more because it's more dominant, and then that's what's more in the gene line.
But
But
what we
that blue
don't
up
what
in
we
it,
don't see is people who have brown gene, blue gene, and some other gene. There's only two.
we're only two. Well, yeah, brown and blue. Yeah, brown and blue. Right, right.
Yeah, and they can combine differently to make more than one color, but you can't have there's not a third place for that gene or the third or fourth.
Well, how about if they both get that gene, and then the green eye person? Okay, when you said
Because so I'm not exactly sure whether green eyes is like a variant of the blue gene, but the way it would work is if green is like this so totally separate color, then it would replace one of the two spots that eye color has. It would there's not a third slot.
okay, so I see what you
So
say. You saying
you could have a
it will
brown and a
right,
blue, or you could have a brown and a green, but you can't have brown, green, and blue. I'm
okay,
pretty sure green is like a combination of blue and something else, but
right. But you can still say that you know mutations for the most part, for the most part, mutations seem to lose information. Something you can get it's like that's like a football team that's 3-16.
well, it's
They
more
lose three.
likely.
What look was so they lose 3 games, they win one. Oh, there's a game. They lose three more, they win one. Oh, there's a game. You lose three more, you win one. Yeah, you could gain sometimes, and a lot of that game is going to be the recombination, right? So you still got that ability to to recombinate, you know. But at the end of the day, it seemed like there was more, much more um, uh, information from from an ancestors from before. Let me ask you a question: do you think humans is getting sharper or dumber?
Well, depends on how you measure it. We have more accumulated knowledge over the generations.
Well, okay, yeah, right. Okay, so if you, but right, and I get that. But was they sharper? You know, if you had to measure the brain power of, these philosophers way back when, I bet you they'd be sharper than if they had the knowledge that they had. You know what I'm saying? With over time, of course, you're gonna get increased knowledge, but they're not sharper. Matter of fact, they was talking about that what's that library, the Library of Alexander, that got burned down.
Yeah,
What if they would have had them books? Probably civilization would be much sharper than it is right now because they lost a lot of knowledge.
yeah.
But I don't. I think humans are getting stupider. I think they're degrading.
I don't know. That's just speculation. I think that there's a lot of unhealthy things that we've invented with technology,
Right.
social
That's
media and
definitely.
stuff.
I agree with
It
you
can
on that.
be it's kind of a double edged sword. So
I can agree with
We
you on
have
that one.
we have instant access to knowledge, which can
You
increase the
got
amount of things people know. But
that's
it's
true.
also
But you got liberalism too, though. These women, thinking they the boss. They want to be the boss. You know what I mean? That's messing everything up. What do you agree?
no. I think there's a lot of great female minds out there who can do science and
But
art, and
should they be the boss in a relationship?
it,
Should they be the
it just
boss?
depends on the relationship and the
Or if you
individuals.
gotta, if you yeah,
I
if you
don't
gotta,
think I don't personally. I don't think someone being the boss in a relationship is the healthy way to look at it. I think it's a partnership, an equal partnership.
but let me ask you a question. Do you think that women are more likely to make emotional decisions instead of decisions that's rooted in common sense?
Not necessarily. I think men are
All
can be
things being
quite
equal,
emotional, especially over women.
all things being equal, yeah, that's
A
because
lot of
we
a lot of
we allow
the most destructive criminals are men making emotional decisions, like mass
right.
shooters.
Well, that's because true enough, but see, that's because they probably well, okay, I mean, come on, you can't really now you go into the extreme. But I'm saying for the most part, men are made to lead and women are meant to be the follower. If if
Maybe that's
if you
even
had
true. I don't even have to disagree with that, but there are
good,
women who are better than some men at leading, and so they should be allowed to pursue that. And
okay, right.
maybe they're the
That's if
exception
you
to
got
the
a
rule, but
if you got a weak band, true enough. Yes. But all things being equal,
but
all
humans are
things
not
being equal.
equal.
But okay,
There
well
so
you
there's
you
this
gotta have some kind of grading.
there's
You
a
gotta have some kind of
phenomenon
grading scale.
there's a phenomenon where there are more intelligent women than there are intelligent men, but there's also uh so what is it, the average intelligence of women is higher than the average intelligence of men, but there are more highly intelligent men than
But that's I gotta
highly intelligent women.
I
So
want to look at that
so
stat. That's pretty interesting,
there's
though.
more dumb men than dumb females, but there's also more smart males than females.
Well,
And most women
you gotta
are,
send me that one. You gotta send me that one. I need to know about that one for sure.
yeah, so most women are more intelligent than half of the men and less intelligent than half of the men.
Well, yeah,
but
that's a
but
pretty
there are
interesting.
still some highly intelligent women, and they should be allowed to compete with their skill level.
Right. Well, I tell you what. Let's get back to let's go. Okay, I tell you what. Let's talk about well evolution. Okay.
Mm-hmm.
So basically, do you think well evolution is how would you grade that as far as the fossils leading up to it, as far as it being, a well understood theory that there's a lot of evidence for well evolution. How would you grade that?
I'd give it an A.
Oh, come on, man. Why?
Well, we have, so there's, I think it's called the auditory bulla, is present in only whales in extant species today. And we find these structures in,
I never heard of that structure. What is that again?
it's part of the ear.
Oh no,
Or
that's
maybe
not
that's,
you saying that wrong. You definitely saying that wrong. You're talking about yeah. You're saying that wrong. Uh, there is a they found that in mammal, and then they found it in whales. It's a bone in the ear. You're just saying that wrong. I know what you're
yeah,
talking about.
I might not have the name right,
You,
but
you're just pronouncing it. It's kind of, I mean, it's kind of like the spelling is okay, but you're pronouncing that wrong. So yeah, there is a bone, and that is how they that is how they came up with, you know,
Yeah,
whales
because
being.
Pachycetus
It's
is
called. I think it's
unique
called
among
a
land mammals for
invocalucrum.
having
It's
that.
called. I think it's called an invocalucrum. It's an invocalucrum. They found it in this one called Indohyus, which is one of the first, which
Yeah.
one of the first ones, first whales, what they said was a whale. So the invocalucrum was found in an ear. Okay. And then that right there was enough for them to say, "Oh, the whales evolved from this Endohyus and then Pachycetus," and that was enough for them to make that claim.
Well, it
That's
it
not
was enough
enough.
for them to say likely, and then
That's
after that,
yeah.
they filled in transitional forms, which basically further confirms the hypothesis that yeah, this is likely connected to the whale lineage because it has this bone that's unique to whales, and yeah, I'm forgetting what the actual name of it is, but
And Volcalucrum, yeah.
um, but they so this was unique among like Pachycetus and Indohyus for land mammals, but then they
No,
found
I think it was just no. It wasn't in
semi-aquatic.
Pachycetus. It wasn't in. It wasn't in. It was in. It wasn't in Pachycetus. It was just in Endohyus.
All right, I'm gonna have to check on that, but um, so they, I think they had hypothesized that whales were related to more closely related to hippos before that, maybe after that. I don't know, but
Wow.
they started filling in transitional forms for these. So there was a semi-aquatic one. I forget some of the names. I should pull it up. But basically, that there was this same type of animal, but it was semi-aquatic. So, like, should we just take it step by step? Is it possible for a land mammal to evolve to be semi-aquatic?
Um. Yeah, I mean, you have some today. I think what it is so
Yeah, like
basically you got Pachycetus.
AIG says that otters are evolved from
Yeah, yeah.
weasels.
Well, I don't know about that one, but you do have ones that kind of both. So you got Pachycetus, I think you got Ambulocetus, Myocetus, Cuchacetus, Rhodocetus, um, Duradan,
Durodon,
Duradam, and uh, the Balasaurus, and then you got the blue whale.
Basilosaurus.
Yeah, yeah, right. Then you got the blue whale. But the thing about it is, the only one you
Well,
really,
it doesn't go straight to blue whale
right. Okay, I
because
see what you're saying,
dolphins are more similar to the
but
Basilosaurus.
but here's the thing. Here's the problem is, you know, do you understand what it takes to become a whale? Because all of those creatures, except for Balasaurus or Dorodon, really had they had hind legs, and they had all these different features that has nothing to do with a whale. They didn't have a blowhole. They had the hind legs. They had the front legs. They didn't have none of the features. They didn't have the blowhole. They didn't have the
But
dorsal fin.
they look
They
like
didn't have.
whales with
No, they really did
hind
not.
legs with hind fins.
They really did not. They certainly did not. What it takes to become a whale is a marvel
Well,
engineering.
Dorodon looks like a dolphin.
So so so, so here's the thing. What you're doing is you're just putting creatures together, and then it doesn't even necessarily mean that whales and dolphins basically evolve from each other from there. So basically, how do you get a blowhole? How do you evolve a blowhole? honestly. And a blowhole is it's connective fibers, okay? Highly elastic fibers on the top of the head, like right, if I'm not, when
Like
I'm mistaken,
nostrils?
right, well, that is their nostrils,
Yeah.
right? But
Is
what I'm
there
saying is, how do
the first question is there any reason why this isn't possible?
yeah,
So so looking at dogs, we know that and bats actually, we know that the facial structure can change so much that the nose can basically go from like a dog, the traditional dog nose, to being almost right up to the eyes.
no, it's
And a
not my.
blowhole and like pugs, they do
It's
have
in the
breathing
same
problems,
spot. It's just
but
longer or
bats
shorter.
don't.
It's just longer or shorter. That's all it is. Is longer. You got a longer,
So
what do you call it? Mouth, beak, or whatever. Not beak,
yeah.
but longer mouth or shorter. That's
So you're
all you
saying the
have.
nose can't move position on the head?
It would have to. It would have to move. The difference between those two is that for one thing, you have to evolve a nasal system nose to a blowhole. A blowhole is a very complex engineering. The muscles in there, the fibers, the tissues, and all that stuff
But it's all
is
stuff a nose already has.
no, it really isn't. The connective fibers on there is way different than a nose, completely, and it just migrated way on the top of the head. I'm not going to say it went through the brain because it's in front of the brain. So some people try to say it evolved through the brain, but it did not. We
Yeah.
ain't saying all that. But see, not only that, listen, do you understand that whales have they have floating collapsible rib cages so that they could do those deep dives 2,000 meters. If their rib cage was the same, okay, if they wasn't detached, they would collapse their rib cage because of the deep dives of the pressure. Okay, so they have these detachable, um, collapsible ridges that's not even attached to the sternum anymore. It's kind of parallel. It's so different than regular mammals have. Then not only that is the fact that they can die for 2 hours. They have more myoglobin in their blood. So you got those two features, right? Then you got the fact is that whales have their testicles are inside their body, right? So because their testicles inside their body, they basically have this system, this countercurrent heating cooling exchange system, because the testicles need to be cooled like the body, cooler than the body, even though the body is super warm. So they have to have a system where blood flows from both the flute and the dorsal fin. It flows and it actually warms up the blood so that the sperm production would actually work. It has to be several degrees lower. Not only that is the testicles migrated into the body. So that the two of those systems together is the only reason why a whale can have offsprings. If why would the testicles migrate inside of the body? Okay, if you didn't already have the cooling, the counter exchange heating cooling system. So you have a complete system here where this blood flows through a network of veins, pass through the arteries, and it just kind of just flows, cooling the blood that's already hot, cooling before you get to the testicles. Not only that is, the way they have birth. Well, whales they birth is feet first, where mammals is head first. So now you change the birthing method. Part of that is because of the fact is that whales they need to nurse underwater, and they got a complete system that allows them to nurse underwater. Okay,
And this
if
is
they
all
came
whales
out,
today. So
yeah, absolutely.
So
So all these
and you're not
things,
disputing that the skeletons can evolve like that?
I'm very much refuting that. See, here's what you're doing.
So like we have fossil evidence for skeletons, so we should start with that.
But you say you say they're fossil. You say that they're fossil evidence for those skeletons, but they're not. The same way they were saying that. See, the thing about it
Well, they
is
are
these biological.
fossils. The question is whether they're whales.
Oh, okay, good. Okay, yeah, you got those fossils, but those fossils look very distinctive between either they were a mammal or when you get down to Durodon, it's kind of like a dolphin almost, and Balasaurus, that's a whale. But the ones in between then,
There's only minor
and matter of
differences between all of them.
it's complete differences between those ones. All you're looking at is you're finding a shorter leg creature and saying these legs they lost some kind of Hox gene. They lost a Hox gene, and this Hox gene, made the whales lose their legs. But again, like I was telling you, uh,
But if the whole body is the same except its hind legs are just
it is
shorter,
it absolutely
how do
not.
we tell if those are related or not?
It looks completely not alike. Okay, it looks just not alike. And like I said, anyway, the Hox genes that's responsible for the losing of the limbs. Okay, you put those in the mouse. It's not even the same association. It's not even the same association. They're expressed in different locations. You can have the same genes, and those same genes are expressed differently and in different locations and different animals. Humans and mice have a lot of the same genes. They could be expressed in different ways and in different locations. But the whole thing about it is, how do you build these networks? That's the main thing. You can say
They're
a
mostly
lot of
already
research.
there. So we
It's
can
not.
get to the soft tissue, but like the Myocetus skeleton looks exactly like Dorodon, except
Wait a minute,
shorter
mycetes look like
tail
that?
and longer back legs.
I don't think so. For one thing, Myocetus was look like who? Doradon?
Yeah,
For one thing, in between Myocetus and Doradon, Myocetus was actually much smaller than that. Okay, but the thing about it, from Myocetus to Doradon, you got Rhodocetus and you got Cudocetus. Cudocetus looked like a damn look like a damn more like a seal. And then you got Rhodocetus. And Rhodocetus didn't even have a fluke tail. Okay, they assumed that it had a fluke tail. Gingrich admitted that he assumed that it had a fluke tail.
yeah.
A fluke tail is a fluke tail is just not a tail. It's engineering. A fluke tail has separate muscles and tissues and nerves that actually controls versus a tail that basically where currents basically control it. Okay, a fluke tail it has a nervous system connections where it can move independently. Okay, so that's not the same thing at all.
It doesn't need to have a fluke tail. It could
Well,
have a flat tail.
what's the name lied? I tell you, Gingrich lied. He admitted it later. But the
Well,
thing about it is,
in paleobiology, they make some assumptions because they don't have much soft tissue evidence. So that's
yeah,
paleo
but
art.
that's kind of, but you painting that picture, it just don't,
Yeah, that's an
it just
unknown, but they still depict them.
don't say that it is. Don't say that it is. And then what about the time? They found where. Listen, it was believed that well evolution, the time from Pakicetus to modern whales was 8 million years. Then they found a whale fossil like where like we only gave them 1 million years. So now you're relying on evolution to build a well, and from Pachycetus to whales in 1 million years. I
That's a
mean,
long time.
it's insane. 1 million years,
Yeah,
not according to evolutionary standards. I think it's a tremendous amount of time. But the problem is you got to go you got to go by how often beneficial mutations occur,
but
and
mammals
then you got to go.
themselves are also similar. So a million years isn't. Once you have the mammal body plan, it's not a lot of changes between the mammals. So Myocetus, Cuchacetus, and Rhodocetus are they're all basically the same type of animal that looks like it's kind of an aquatic, like almost like a wolf.
Wait a minute, let me ask you a question. Do you know how they calculate how fast mutations can get fixed into a population? It goes by breeding, how much you breed, how you read, how you can become an adult, how much you reproduce, and all that kind of stuff. So uh, I think it was Sternberg. You know, he did a study based on the akapa, how you have a giraffe and you have how you got the akapa, and then how long it takes to evolve a giraffe from a kaka, right? And he said that it takes um, there's about 46 distinctive neck genes that from if you were going to evolve a giraffe neck from a coppice, right? Over 11 million year time frame, you know. But when you talk about these walking whales, okay, from fully aquatic, from fully aquatic, um, uh, crus- uh, um, not crustaceans, but cetaceans, okay. It takes 2 million years. I mean, to get two mutations fixing in a population takes a very, very long time. You don't have enough time there, according to evolution. You don't have enough time to get two fixed mutations. They say can take up to 100 million years, considering the fact of their breeding, how they breed. Now, even with the fruit flies, you know, it takes to get two mutations and regulatory genes take a few million years. And we seen what happened with the fruit fly experiment. It was a straight bust because you got these extra wings, but yet you don't have the regulatory networks inside of there and the muscle and skeletal support to support them extra wings because it's only built to have muscular, not skeletal, but muscular and nervous support for the two wings. So when you add extra wings, you got a mutation. You got a creature that don't flourish. You think that fly would have been able to fly extra fast or been able to maybe, I don't know, float or whatever, do something. You got four wings and they end up dying. They don't survive outside of a laboratory. So you just don't have that kind of time. And that's when you want to get into rapid evolution. Now, to me, rapid evolution is not evolution. To me, that's creatures evolving on the fly through epigenetic modifications based on an intelligent system that's already fully formed, okay? Fully formed operating system, and it just adapts to it. So, it depends how you want to define evolution. If you want to reduce evolution down to changes in allele frequencies, um, you know, dealing with a fully formed creature that can do some quite a bit of changes, I'm on board with you. I mean, if it's that, I'm with you. Other than that, when you talking about coming from single cell to humans, monkeys, chickens, turkeys, no, that's not happening. So that's just my take on it.
So based on, well, mutation fixation rate is also variable, but so the Myocetus can't evolve into Dorodon because it
Oh,
doesn't have
well,
enough
for one
time.
thing,
Is
that
that what you're saying?
doesn't have enough time. You got I don't think there's enough
Why
genes in the
wouldn't
gene pool that can do it.
why wouldn't there
I
be
don't
enough
think that
time
there's
to elongate the tail and shrink the hind limbs?
well, I need to, well to shrink the because I think that you do all that, I think it's going to end up going extinct. You know what I'm saying? Because it probably won't flourish in this environment. It may get taken off by something else. And then they got to get fixed. It's got to get time, got to go by or whatever. You know, you have to have that mutation that's going to actually,
Well,
you know,
how long do you think it would take for Myocetus to evolve a population just with bigger tails?
I gotta look at mycetes and see exactly what it looked like. Because here's a problem with this. The problem with this is they keep on changing how these creatures look. See, yeah, I'm not sure if I even know exactly how it look anymore because they keep changing the way they look.
Well, I just go off the skeleton because the paleo art
Okay,
is drawing on modern animals, and it's
all
basically
right.
speculation, pure
Okay,
speculation.
let me see. How you spell? Let me see. How do you spell mycetes? Let me pull it up. Mycetes.
Maia
Wait a
cetus,
minute. Maiacetes.
cetus.
Yeah, ET. Yeah, that's what I got. Mycetes. Okay. All right. Let's see what it looked like exactly. I remember what it looked like. Okay. Let me look at images. I want to look at the skeleton. Oh, okay. So you got, oh, man, how is it going to
And
turn into a
compare
what?
that to Dorodon.
Okay, hold on. Okay, hold on. Okay.
The
All right. Let
skull
me,
is like identical.
okay, Duradon. Okay. Durandon. Is that what it is?
I think
Dur,
it Dourdon. I think. Is that what you said?
oh, wait a minute. How you spell it again?
D
DA. That's DA. I'm sorry, D what?
Dourdon.
All right. Okay, let's look at the skeleton. Okay. Okay, so this one does look closer to it. Let me see something. All right, so let me switch back and forth. Okay. Well, they got the same kind of mouth, like, okay, they lost the legs right there. Um,
It still has little back legs, though, right?
right. Well, the thing about it is, yeah, that you got, oh, okay, yeah, you do got, you're right, you got little back legs. Okay. Yeah, yeah, they do got little back legs, but but it's still losing. It's still it's still losing that structure. That structure. How do you lose that structure that holds it to there? That's not even a leg. That's a foot. It got a foot basically on there.
Yeah, I mean,
I'm sorry.
there's just natural variation between parent and
No, man,
child, and
I
so
can't. I
so
don't know about that one, dude.
the children that have smaller back legs, like once it has a powerful enough tail,
That's not even a.
it
But it depends
doesn't
on what you're
need
looking at.
there stops being any selection pressure on back legs because they don't need them to
Okay,
swim anymore.
but see, but here's a problem. Here's a problem with that is evolution is blind. Wait a minute. See now it look like they're not even sure if those legs were there. See, because I'm looking at this one picture, and then this picture don't have legs on it. Then you look at one, and the legs is not connected. They just kind of just got them floating there. That could be a fin. You don't know what that is. It
Are
depends
you
on which
looking at the
picture you look at.
skeleton?
I'm looking at the skeleton. And one of them, a couple of them, is just look like they don't have the connect. See what it is? It looks like they completely lost the connection. Most of these, they're not even showing the leg connected. They just
Yeah,
showing it just
their
there.
pelvis isn't connected.
Okay, I see what you're saying. Now, when you look at this one right here, well, that could
But
be,
that's like modern whales.
so that could be just a fin. You don't know what that is. But I
Yeah,
see what you're saying. I
but
see
well,
what you're
it could
saying.
be a
It
fin,
is
but it is definitely, it has the leg bones
it
in
is
it.
closer, but that's no different than that's just no different than them putting lining up fossils. We don't know. Okay, so let me say something to you real quickly. Now you do realize that most creatures that they find, most fossils they find in sedimentary rock, right? All of them basically. Well, no. Well, I guess you got volcanic rocks, right? But you got sedimentary, you got volcanic. What else you got where you find fossils at?
I'm not huge on geology, but that's mostly what
Well,
they're found in, I
you have
think.
to have a rapid burial, right? You got to have a rapid burial, right?
In most cases, to preserve it.
Well, okay. Well, how do you know, you can't. You're
Sometimes
not finding
there's
fossils in sand. You're not finding fossils in sand much, because unless you got a sandstorm that that really like very powerful, and then it get engulfed, and then there's no oxidation or whatever. You know what I mean? But for the most part, you find them. You find them in floods or local floods or worldwide floods,
or
right?
really dry
That's,
places,
nah, you still gonna get
sometimes
it, but you still
swamps.
gonna you're gonna get predators. The predators gonna eat it up. You got
Well,
bacteria. You
there
got
are I think that mass dinosaur grave that everyone talks about, it has evidence of predators eating those bones. There's tooth marks on all of them,
that was after the fact.
and they're
That's after the fact though.
well,
But
they
the
died
fact
and
is
were half
preserved.
buried and
They
were
died,
uncovered
and
and then buried again.
no, they died, and they were buried, and then you got creatures that bury into the soils. It might have been on them, whatever, or they could have. The bite marks could have been before then. Who knows? But the fact is that you got a volcano erupting, right? Or you got sedimentary. Whether you got a local flood or you got a worldwide flood, right? So here's the thing: you got a local, you got a worldwide flood. Guess what you got? You got fossils mixing. So I don't
But
agree
then
with them saying,
there's layers in between that can only form in extremely dry conditions,
"What are you talking about?"
like certain
Uh,
sandstones.
Sandstone is from water. What do you mean?
Well, there's some sandstones that formed in wet conditions and some that are formed in dry conditions.
Some sandstones form. What sandstones is? What sandstones in between layers was formed in dry conditions?
I think the
Don't you got it?
Kaibab sandstone and Grand Canyon.
You got no. I don't think I need to look that one up. I need to look that one up. I ain't heard of that one. But for the most part, you either got a worldwide flood, you got a local flood. Okay. So if you got a worldwide flood, you got a local flood, you know, you got fossils mixed up. So I don't agree with that. You got this beautiful transition from this and that and this and that. And a lot of times you got out of place fossils. Even with this well evolution, those wells wasn't found in those exact correct places. They basically lined them up, you know. And let me ask you another question: how much spacing in between layers? Like when you find some bones in one layer to the like it could be what, a feet, 6 inches. I mean, how deep is all the layers itself? You know what I mean? For you to make the determination, because where they're finding these fossils, you don't know if they found them in that exact location. Because guess what? Now you may not want to go along with this, but I will. If you said you found a fossil in the wrong location and it was in totally somewhere different, you're going to get scrutinized. They're going to call you a liar. They're going to call you a dirty bastard. You're lying. We don't trust you. We don't believe you. And it probably won't get published. You'd have to almost say that you found that fossil somewhere different than where you found it at for them to take you seriously. And here's the killing part is, why do they ask what layer you found the fossils if you wanted to get radiometric dated? Why they gotta ask you? Why they gotta know?
Well, it's because different date ranges require different calibration.
So you can so the story will work. You know what? If radiometric dating was that solid, they should be able to bring a rocket. They should give you a range without you and it shouldn't be no huge range. And rocks with known ages should show those known ages of those rocks. Could you at least agree with that?
I'm sorry, I didn't really get that.
Known ages of rocks. When you radiometrically date a known age, that known age shouldn't say millions of years if you know it wasn't millions of years old.
Oh, like a recent eruption?
Not necessarily recent. 2,000 years ago, when we know certain volcanoes erupted, 1,000 years ago, maybe 3,000 years ago.
Well, they've dated Vesuvius, and that was accurate.
Oh, I don't know if any. No, okay. You see me a link of one that was uh, that was dated accurately. That's and what year was this? Was it a volcano eruption? Is that what it was?
Yeah, Vesuvius, isn't that the famous Roman one that
And it was
that
dated.
cover out all those people in ash and it's like
How did
preserved?
they? How did they date it though? What date method did they use?
I don't know.
Okay, so that's something we got to look at because anytime when they ask you when you want to date rock, if you want to rock dated, they ask you where you found it at. They want to know, and then what they do is when they radiometrically date it, you get a range of dates, and you're allowed to pick the date that you like the best. And that date you're picking is going to line up with the geologic column, and then you're going to get published, and they're going to give you a parade. A couple of girls are going to come in, get on their knees, and give you a blowjob, and they're going to give you some money.
Wow,
Okay,
that's
but if you try, but if you try to say that this was found in a layer that's completely contradictory to evolution, you may have a serious problem getting that paper published, and you will face vicious scrutiny. Okay, that's just how it goes. That's the game.
peer review is always vicious scrutiny.
There's
So
different levels of viciousness.
so there have been cases where they've dramatically expanded the range of certain species,
Yeah,
and they do scrutinize that because they want to make sure
they
you're
do.
doing your work
No,
right.
the reason why they do that is because if
But
it's
then it gets
something they can't.
published and it changes the scientific consensus.
Well, here's the thing. It depends on. It really depends because if they just absolutely cannot refute it, then they have to change it. But then they have to create a rescue. Like okay, let me give you a prime example. This James Webb Telescope. There were some predictions made about it because this thing is able to see much further than any of the other telescopes, and it's able to see galaxies way far away. That's so far away that the light did not get to us yet. These galaxies is not supposed to be. The galaxies are supposed to thin out as further we go back because the light hasn't reached us yet. So you should see semi-formed to barely formed to almost no formed. Well, the problem is as far as they go back, way past 13.7 million years, almost 18 billion years, they're seeing fully formed galaxies, and they're seeing signatures of heavy metal that wasn't supposed to be present from the Big Bang because you're supposed to only get like helium, not is it hydrogen, and I think helium. I can't remember exactly, and maybe not even oxygen, helium and hydrogen mainly, was you're supposed to get. But now they're seeing heavier in astrology they call it heavy metals. You're getting these heavier metals far away, and you're getting these rescue missions right away. Galaxies seem to form faster than previously thought. This James Webb telescope is really hurting. I mean, it's really. I mean, of course, they're not
Well,
abandoning what they're thinking.
I mean, what's the problem with them discovering, oh, this thing just happens faster than we thought?
Well,
Since
here's the
we now
problem.
have more information and it seems faster.
Well, but how
What's
we
wrong with
just know
that?
we're not?
It's
How,
like
how do we
the
know we're not wrong?
I don't want to abandon the whale topic. It's like when a creature evolves more the ability to absorb more oxygen in the blood. Well, that trait was already there. They're just getting better at it, or they're better at going into higher pressure. All those same
Well,
traits are already there. They're just getting better at it.
but what tells the story the best? That they evolved all these features in almost no time.
But it's not
They
about telling
wait
the
a minute.
better story.
Let me. Well, hold on. Let me just finish. Let me just finish. They evolved all these features in almost no amount of time. They evolved different mechanisms like the detachable, collapsible rib cages, myoglobin. They migrated the testicles inside of the body. They designed a countercurrent heating cooling system. They
Mammals
completely changed. They
mammals
completely
have
changed.
that.
They don't have no. They don't have anything that. I think birds have a counter current
Well,
airflow system,
dog
but
dog
but
paws have that to warm up their paws.
but they don't have. We talking about blood flow from the dorsal fin. They evolved a dorsal fin, which which moves independently with a neurological nervous system, okay, and muscle fibers and tendons. And then they got the dorsal fin, which carries blood through this system. They got a blowhole, which is really complex fiber material, and they can deep dive.
But
And they lost their limbs,
but
and they got all this other stuff.
independently, each one of these changes is functional on its own.
No, because why would you have internal testicles and a heating changing, a heating, cooling, exchange network? Why would um, I- if the
The
testicle
skin the skin
vibrated? Oh,
already
wait,
has like thermal cooling properties like in mammals.
not
That
not for deep sea diving with the pressure, and not because you have to keep the testicles cooler than the body for reproduction. So what came
yeah.
first? The migration of the testicles or the heating, cooling, exchange system that's not necessary because the testicles is outside of the body.
Well, it was probably a retraction of the testicles and not it probably didn't fully go inside the body first and then start
Retract
working on the coolant. system. It was probably they got smaller, they got closer to the body, and they started modifying the coolant system around the skin of the scrotum or whatever.
Well, why would it do that? Well, I mean, what would be the reason? I mean,
And plus,
so what? So what? It
plus
what?
the
That's
body can
like
adapt on its own. So the
okay,
mammals can heat up or cool
but how
down
can it?
parts of their
How
body
can how can
already.
evolution? How can a blind process be the process in which the body adapts on its own? Why would the body know to adapt? Why would the body have these sensors and these detection systems that allows it to adapt? Where would that come from if it's just chemicals, blind chemicals? Blind chemicals, they don't think.
Well,
Blind chemicals,
certain systems are already have a basic level of intelligence. Like you can say that the system in your body has a sort of intelligence because it's able to know when you're cold and when to
where
start
did it come
burning
from?
fat.
Where did this come from?
This was already in mammals.
Already in, but when it was a cell, it was already in. It was already built into the cell before
Well,
in a single cell.
we're just talking about um,
When it's a mammal
mammals.
already, okay, but it has to get there some kind of way. It has to get there. It just can't just evolve on its own. It has to be. It has to get there. See what it is you need to be you should be what do you call it? Hi, my brain is drawing blanks now. The type of evolutionists that believe in God will push stuff. Theistic evolution. You should need to be a theistic evolutionist, because you want to believe that this stuff happened on its own, or you want to start with that. If you want to start with that, you have to say God put it in these systems, and then from those systems, he laid the foundation, and then from there, boom, we got evolution, and you could make an argument for that.
Well,
Yeah,
you
theistic
can.
evolution. Go
A lot
ahead.
of times I say you can just assume God made the cell and then knew how everything else would evolve on its own. And to me, it's a much
To
greater
do
God
more, he would have to do more than that.
who can make life that will evolve on its own without his constant intervention. That's more impressive to me. Like that takes more intelligence and more planning.
No, because it really depends on. So he would have to have designed
Are you still there?
it. Hello.
I think you dropped for a second, but you're back.
No, that was getting a call through. I guess when you
Oh,
get a call, it knocks it off.
yeah.
So no, he would have to. He couldn't just design a cell, one cell, and then just go back and start doing his nails. Okay, he would have to do a lot more than just design a cell, because this cell needs to be able to, you know, create all the creatures, you know, on the planet, and it would have to be able to, it's kind of like second law of thermodynamics, man. Everything it turns toward disorder. You know, you can't go upward. You got it goes down. Even
But
when you
not
get
if
complete
there's
creatures.
energy introduced into the system.
But
So second
okay,
law of thermodynamics just means that the total amount of energy will basically even out.
decrease. It means decrease.
No, because you can't really decrease the total amount of energy.
The amount of work. Why do they believe? Why do they believe Why do they believe that the universe and the world will basically use up all his energy eventually, and it's just gonna get cold and go cold and dormant.
Well, that's what heat death means is that not that there's no energy, but that it's all evenly spread out. So
No, they
basically
means that everything is gonna
heat and
use it. It's gonna
energy
use the energy.
energy is really misunderstood. Energy is not like a thing that gets spent up. It's really where energy comes from is energy differences. So there's like a type of engine that will run basically if one of its plates is colder than the other. And it doesn't matter what temperature it is. As long as there's a temperature difference, it will move between the two plates and create mechanical energy. So heat death is when all the energy is evenly spread out. And so it no longer moves from a high energy place to a low energy place, and thus nothing happens. So it's all about energy differentials. Concentrations of energy causes movement towards concentrations or towards low energy concentrations.
So you don't feel like at some point, like even when they looked at like okay, even when secular scientists looked at certain planets and they were expecting that planet to be dormant and dead of energy because it was nothing that was regenerating the energy. And then when they went and they actually sent the messenger and these different probes, and they realized that planet had a lot of energy in it, and they looked at the size of the planet, and they felt that the domino that's inside, which is the you know what a domino is inside of a planet. Do you know what that is?
No.
The molten lava that's inside of the planet.
Yeah.
They the bigger the planet, the more lava that it has, because it started off as a molten lava, and then it cooled and everything. So a bigger planet will the lava it will cool slower, right? So therefore, a smaller planet it would have cooled and it would have lost its center, which has a magnetic field on it, right? So um they was expecting for I think it was Venus and Mars not to have a magnetic field, but they did. A lot of planets had magnetic fields. They was expecting wasn't having a magnetic field because of the fact is that they die. They were expecting Venus to look just like Earth because it's a sister planet and they seem like they formed at the same time with the same materials. But Venus looks completely different than Earth. It has all this sulfuric acid, super hot at night, extremely cold. I'm sorry, hot in the day, extremely cold at night, and it has all this sulfuric acid. It looks completely different than Earth. So that kind of threw them for a loop, you know. So they, of course, came with their rescue missions. You know what I'm saying? But I'm getting way off topic here. Um, I mean, I just feel like you can't be even from a cell. You need God's imperfect intervention. Like say for example, you know how men go into puberty, right? You get genes get turned on. The histones. You know how epigenetics work, right? You get the loosening and the tightening of histones,
Mm-hmm.
right? And that makes this DNA information available for transcription. Because you can't transcribe something if it's on a histone and it's just so tightly wrapped. You have to loosen it up so that you can actually get the transcription. Well, what would be the mechanism of evolution that would detect a certain time, a certain maybe even pH in men? Say, hey, okay, it's time to go to puberty. Let's unwrap this DNA and let's send the RNA polymerase to copy that information, and then let's tell the spliceosome that well, this is a puberty hormone, or this is a puberty gene that we want to activate. Okay, so you're going to have to not add exons 2 and 3, We just need, 1, 4, and 5, right? So we're going to snip those ones out. Then we're going to add a polytail on the end of it, a bunch of alganines at the end, and that's going to help it, stop the from degrading, and then it's going to send out the nuclear core complex, which which recognizes what's supposed to come in and out of the nucleus, and then we're going to have tRNAs going to meet over to the ribosome, going to meet over to the, it's going to carry the correct amino acids, which is going to follow the template that left that went to the ribosome. You're going to build these proteins. This stuff is all purpose. How do chemical reactions uh, order this type of complexity?
That's under a lot of study, but a lot of the times they figure out how it works. So
You,
you're just giving a lot of examples of this is complex and therefore it can't have evolved.
yeah, but at what point do we say maybe it can't evolve?
Um,
I mean, at what point do we say that? Is anything possible? Is everything possible?
well, the theory of evolution is very powerful in explaining in explanatory power. So that's the number one hypothesis or theory that scientists are going to use to explain things because it has been able to explain a lot of stuff. If a god shows up and shows us how he did it, then that'd be a pretty good confirmation of intelligent design.
Yeah, but that's not in God's nature to do that. A part of the whole idea of God um, is that, well, honestly, is faith. God. I mean, God don't want to just reveal himself like that. That's not his nature. But his attributes are clearly seen when you look at the cell and you look at this machinery that's in the cell. It's clearly seen. It's just you refuse not to see it. You got that's just one facet. Well, like I was telling you about the kinetochore. This is involved with cell division. You got all these machines running across um, microtubules, and then as a cell divides, and then you have to, you got these chromosomes, right? And it's gathering the information from both chromosomes, and they split it in half, and they're forming another cell. You know, um, it's certain uh, uh, reactors that react to signals that starts this whole process, and then you got two cells. How do you evolve that? How do you evolve mitosis and cell division?
Um, there's a lot of experiments going on about those very questions. So if we knew everything, then the game would be over. But since everything looks like it's a variation of something else,
It's part of,
this is guiding us and giving us new information all the time. The assumption that everything is created doesn't really help us do anything in science. And
uh,
it's tempting to say it's super complicated. It must take some huge genius to figure this out. But we've discovered processes in nature that create really complex
like what?
patterns,
Like what?
like evolution.
No,
So
well,
there's real evolution in
well,
nature.
that's what you
There's
say. That's
evolution
what you say.
experiments on biology, and then there's evolution simulators that are either simulating biology or they're used for artificial intelligence. So we can't actually create artificial intelligence by design. We have to evolve it because evolved structures are often more complex than human minds can even keep track of. And with variation and selection, you can get really highly complex systems.
But how you gonna get something to evolve get if you don't put an intelligent design product in uh in there that allows it to evolve? You have to start with a design, okay, and then allow it to evolve. But the way you allow it to evolve is you put it in mechanisms that gives it the ability to go in this direction or then go in that direction, you know,
But
and
you
that's how
don't.
you do it.
But that conclusion is derived from the God of the gaps fallacy.
Well, I mean, I don't know how else it could be done. I mean,
Yeah, that's the fallacy of incredulity.
okay, but
So you might be right, but with that reasoning, you can't use that reasoning.
see, I don't like the God of the gaps fallacy because of the fact is that we it's not that we don't know, therefore God. Is that it's really that we do know, therefore God. We do know that these systems and these things require forward thinking and intelligence.
But how
This
do
is
we
what
know
we
that?
do
Because
know.
there's more and more of these systems we discover every day that don't require that.
But
So it's
we don't know if it require it. I mean, we know that it does require it. I mean,
well, we don't
there
know it does require it because we have no examples of creating anything that complex from intelligence.
because we're not we do we got space shuttles, we got TVs, we got iPads. That's all created from intelligence,
But
you know.
that's pretty simple compared to the cell,
And so therefore, you got a more intelligent person then.
and but not necessarily
What
because
else
we
could it
can
be
create.
if we can't do it, and unless there's something else more intelligent than us can only do it, it would have to be more intelligent than us. I mean, that's
Well,
common sense.
I was talking a little bit earlier about the intelligence of the body, where it kind of has this intelligence of having all this input and being able to adapt to the environment, where you could say that in evolution itself is an intelligent process. It's not conscious, but if you some people use intelligence this way where
How you know it's not
it
conscious?
well,
How you know the body isn't conscious?
how do we know? I mean, that's part of cognition is done in the body. Like there's the you hear the concept of the gut brain. Um, but there's cells that can solve the the subway problem or something. I think it's called where there's a slime mold, or whatever that can solve this problem. I don't know if you know about it. It's
Where is some slime? Hold on for a minute. This guy keep calling me. Hold on for a minute.
okay.
I need to send him a text. Hold on, because it keep docking the phone now. And what you say about a slime mode?
Yeah, so there's a problem with in it's like transportation where we're trying to figure out the shortest distances to connect between like subway or train stops,
Mm-hmm.
like the most efficient way to connect them. And there's a slime mold that basically it'll reach out its tendrils to eat food, And it will do this in the most geometrically efficient way possible. And obviously it's a slime, so it's not conscious or thinking, but there is something intelligent in the way that it reaches out and it has a feedback and that it tries another route and solves this really complex algorithm that humans have no uh, mathematical solution for, at least not as good. So,
So
in
you're trying
that
to say,
sense, it's intelligent, but it's not conscious. So, evolution, the process of evolution, is intelligent in that it's very reactive, I guess, is
oh,
what I'm saying.
so okay, so you don't know if that that slime is conscious.
It could
And the thing
it
about it
could
is,
have a very rich inner life where it's thinking about philosophy and and all kinds of things. I don't know.
uh, well,
Probably
well,
not.
I mean, it could just its consciousness could just be based on okay, say for example, if say you were picture yourself as a slime, all right, and you don't really have sight, but you have detections, right, and these detections kind of gives you a different type of visual perception, like from a mental standpoint, where you're able to maybe just see waves, perhaps, right? And
Mm-hmm.
then these waves, uh, along these waves that's going along, right? And then you get like a different kind of wave, like a ting 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 ting, and that's the food, right?
Mm-hmm.
And then you're moving toward the food in a certain way or whatever. And maybe that's kind of what you see, but I'm not 100% sure about exactly how to describe that. But that's could be something what it is. But
Could be.
it doesn't say that, but you can't say that evolution is intelligence. You'd be better off. I really feel like you'd be better off being a theistic evolutionist because it makes more sense, you know, because you really believe in evolution. You really believe that all this stuff happened. You really believe in that you look at these fossils and you feel like that you can see a clear transition, from you know uh, whale evolution and these creatures and dog evolution. Did you ever see that one? The one that they uh, say that uh, bears and dogs used to be is a thing called a dog bear, and there's a thing called a bear dog or whatever.
Yeah.
I can't think what you call, huh?
Yeah.
Right.
I know what you're
So
talking about.
I'm pretty sure you believe that one too. But they did find a fossil that did have it kind of seemed like it had some features of both of them, you know.
Yeah, it seems
But
like all the carnivores are variations of a type of mammal. And the differences between them are so small compared to what we've observed that
well,
it's
okay, I can
both
say one
it's
thing.
both explained by and predicted by evolution.
It's I can say one thing. It's probably smaller. I mean, bigger or better transitions than the well transition. The well transition is garbage. You know,
Um
the bear dog. I mean, it did look a little bit like you could make an argument for it, but I don't know a hell of a lot about it, to be honest with you.
yeah, I mean just look at bears and wolves. Is a bear is basically a big chunky wolf
No, no, it's not. No, no, no.
with a short tail. Yeah.
No, I definitely don't agree with that. So let's talk about human evolution, though. I mean, I'm assuming that you think that we evolved from a chimp like common ancestor, right?
Yeah.
But do you discard the fossil evidence in both the Laetoli footprints, and then the other one was even worse, the one in Crete, that was like 5.7 million years ago. And the Laetoli, I think, was around 2 million. I mean, almost 3 million, I believe. That they walked right alongside, that humans and apes always lived with each other. What do you? I mean,
Um,
do you disregard those footprints of either one, both of them?
I'm just looking up the Laetoli footprints. Um, I'm reading that it's most likely made by Australopithecus afarensis.
Only problem. See, there's a lot of problems with that one. For one thing, they didn't even find the feet for Afarensis. They didn't even find those feet. And Afarensis, honestly, they found the bones, the mixed bone beds where they found Afarensis. Okay, they were in so many different mixed bone beds. It was really only like 20% complete. You know, they didn't have the hands, they didn't have the feet, they had the knuckles. Okay, not the knuckles, but they had the wrists. They had the wrists. They only had part of the cranium, very little bit of the cranium, and they just had a whole bunch of like just disjointed bones. I mean, it was a mess, you know, and it was found. I think it was found 100,000, like at least 100 miles away or 1,000 miles away. So they assumed that it must have went to Lucy, but like I said, they did not have any bones or feet.
On
So
Lucy.
yeah, they didn't have the bones and feet on that skeleton. It wasn't. If you look up the bones of Lucy, you'll see a whole bunch of roadkill, just a bunch of garbage, like disjointed things, just crap bones, just crap. That they barely had any skeleton. They had, and then the killing part about it is, you know, um, if you look at it had like a rib cage of a gorilla, of an ape. It was supposed to have a hip of the human, the spine of a human, the arms of an ape, they said the hands of human, the hip of a human. You know what I'm saying? It was just like
But
every bone was either remarkably ape or remarkably human, and it was found in a bunch of mixed bone beds. I
uh,
mean,
so if it had mixed ape and human features,
that's what it looked like.
then it would be transitional. But it does.
Well, it
I
was
think. I think
distinctively.
even Afarensis has a skull that is halfway between human and ape.
No, it
But
didn't. The
Lucy,
skull
they
was
didn't find
very
feet
consistent
on
with
Lucy,
chips.
but they found feet on other Afarensis.
But those feet were not human looking feet. The feet were chimp feet.
No,
No
they're
afferents.
they're bipedal
Hey,
feet.
no, no. Any any chimp is semi bipedal, but it still got that exposable hallux, which is that hand feet. They got hand feet, but they can swing on trees, and you know what I'm saying. They got hand feet, exposable hallux, that big old. I don't think they got no pinky. They ain't really got no. Is that them curved feet?
And so they couldn't have made those footprints.
No, no, they could. No, because no, they couldn't have because those footprints they look nothing like a chimp foot. It looked nothing. It looked like a feet of humans walking in some sand, just like it. Even the ones in Crete, they look nothing like uh a chimp foot. It looked like human feet. So
So
I mean,
how come they're the scientists are interpreting it as being the same feat as Afarensis?
they
Just
not.
they just want it to be that way. They're just lying.
It depends on who you talk to. You know, you got the paleontologist from Stony Brook, Africa, Stony Brook, Africa. They 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 really dog Lucy. You got it depends who you talk to. The paleontologists who want Lucy to be Lucy to be the human ancestor, they go for it, and a lot of them don't. You got lumpers, and you got what do you call it? Lumpers, and I can't think what you call it, but they have to have. Some people want to lump them all together. I forgot. I can't remember the term right now. You know, a lot of them don't. A lot of them do not believe it. If you look at that video, you know what will help you. It's called contested bones. And what's her name does a, what's her name?
Gutsick Gibbon.
Yeah, Gussie Gimmons. She I, I've posted many questions on her page. She would not answer. She would not answer them.
I mean,
You know,
she's
just
pretty
like
big. She might not see all of them, but
no,
she
you
she's
know,
who I go to for information on apes.
okay,
Um,
well,
so
okay, ask her
she's
how many times.
shown how all these transitional apes have skulls that are right in between the length of human and ape. Their teeth, their jaw shape is right in between
Humans and
human and
apes
ape.
got the same type of teeth, except ape teeth are much sharper. Okay,
Yeah, and
um,
I'm looking at the Afarensis skull right now, and it's has teeth that are more human than chimp and more chimp than human, but right
nah,
in
not
between.
really. It really comes down to the diet and this and that. It has if you look up Alfred's skull. Look pull up the fossil. This missing so many bones is ridiculous.
Lucy is,
It yeah, it's just,
but
the whole
Lucy's just.
cranium.
I think she's just the first specimen. There have been other ones.
They missing all of them. They missing the cranium. They all have so. Have you ever heard this thing called microplasia? I think it is. It's a uh, uh, it's a disease that these mosquitoes bite you and it makes your head smaller. They got like they got
Microcephaly.
yeah microcephaly, right? They got this small uh, even in those Malaysian those little tribal people, they all really small built. They got small heads and they got that microplasia. So they basically got small heads, small craniums. Um, um, the whole island, the Hobbit Island, they got the island where they found the hobbits at. All the people who live over there got them small heads. Okay, so you know the human evolution is terrible. Ask her how many times did Lovejoy have to reconstruct Lucy's hip before he found the hip that he liked. That Lucy's hip was shattered, basically, and they reconstructed it to make like a human hip. Even the
Yeah, I know what you're talking about. So what he did was just take them out of the dirt and see where the fracture was, and he put them together like that.
No, that didn't fit right, dude. But why take him 13? Why it take him 14 times to do it? Why he had to do 14? And then he grinded it down, right? And they talk
No,
about
that
her
that
her
that has been
knee.
shown to be a mischaracterization from that contested bones
No,
series.
why is it? How many times do you think that he had to uh, 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 k- keep on fixing it? I mean, you got to keep on reconstruction. You know, he reconstructed. He was a major one. He did the reconstruction on Artie too. He had to keep reconstructing that too to get it to fit right. I mean, he's notorious for that. Notorious.
Well, a lot of these skeletons are crushed.
Right. But okay, but not the ones that's remarkably human. You got ones like the Takana boy, which was phenomenal shape. He's turned out to be a straight human, 1%. There's no ambiguity. Then the other ones that they found look just like chimps, no problem. It's the ones that's crushed, the ones they say could be either human or chimp, and those are the ones that's crushed. Those are the ones you find, you know, disjointed bones, fragmented bones. You know, and a lot like Handyman. That was the worst. What is Handyman? I can't think of his name right now. Um, he was a jumble sort of all kinds of damn bones. He had a mixture of everything. They don't even talk about him no more. Because he was just a mess. They want to do they want to prove human evolution so bad that they're gonna go in the dirt and just start looking for bones, and then they're gonna build them a hominid out of bones. Just let's just build us a hominid.
So
Just
why
put
would
them
they
in
ever
there.
admit it was it's other
They
scientists
didn't.
telling
They
each
didn't.
other
Yeah,
that their methods are wrong and then they correct it.
and that's the one, right? And those are the ones that, I mean, some of them got some integrity. Those are the ones that just say, "Nah, you ain't
Yeah.
nobody to make us look bad. Hell no. This is garbage." We ain't about to let you, get rich off of this garbage. No. And guess what? The ones who expose them, they get popular for exposing them. So yeah, they do try to expose them. You know,
Yeah, the good
but
science
it,
sticks around.
but it has to be clear though. It has to be clear, good evidence. Otherwise, if it's just kind of like, you know subjective, and then they get in trouble because you go on against the scientific community. You go against the scientific community, you better be on par. You better have some good evidence.
Yeah.
But human evolution is garbage. And look, and another thing is, why do humans the only ones who got rose hip neurons? Those rose hip neurons has a lot to do with our intelligence. Then we got a Broca and a Winoki regions that allows us to speak. Why you think that humans could speak and nobody else can? You know, and if really this is the big one, if humans and chimps, okay, if humans evolved from a chimp-like ancestor, where are the intermediates today that
Why
we
would there
should
be
have?
intermediates?
Because uh, evolution of these creatures wouldn't all happen at the same time. Why wouldn't it be some species that ain't fully evolved?
Why would
They
there be?
because it could be some isolated ones.
They're not as fit for the jungle as chimps, and
It
they're
could
not
be,
as fit for
but
civilization as humans.
no, because no, here's the thing, no, they can live like the pygmies live. They can live like they would actually be very civilized because then they could be smarter than the average chimp and they can hunt them and they can live in a remote area. They would be beautiful. They would. it would definitely be a niche for them. And then they will be able to read like a first grader. But you
Um,
don't find that. Either you find very smart or very stupid. But you could even get these guys that's in a tribe, okay, that's in a tribe who have no type of human connection. You could take them on that tribe as a baby and teach them how to read and write, no problem. You know, can't do that with a chimp.
so what?
What you
We
mean?
don't. Most species are dead.
But why are there some intermediates? I mean, you want to say there's intermediates today of creatures that, like the one creature, like I say, that was very, very good. I got to give you an A on that video, man. If I was a evolutionist, I'd be jumping up and down. You know what I'm saying? But I tell you what you got a lot of evolution. You got a lot of sex scratchers. Like a lot of like they just like be praising. It gets on my the way they praise T Jump. You know how they sound so corny. Yeah, man, it was great that you was able to tolerate them. How would you just get off of his jock strap, man? Come on, stop it.
Yeah, get on
That,
my
that's a
jock strap.
that's a bit. Well, you got that dude Ian Chan on your jock strap. You know what I'm saying? But what I'm saying is they be on his jock strap, something terrible. It's corny as hell. You know. So I'm just saying they should be on your jock strap. That was a very damn good video. You was making some hell of a points for evolution. It's just that I just know better, but you was making a hell of an argument. You know, if the prosecution did get a, I mean, did get a chance to um to come to the stand, you know, your man would have got off real easy. You know what I mean? So, but the thing is, I just see things differently. I just feel like what you were showing was, you know, create heterogamy and creatures that had that function, whatever, because you can't build systems out of nothing. Okay,
Well, it's
so,
not nothing. It's
but
modifying systems that already exist.
but if you believe, okay, true, but still, if you believe, but okay, but you can't build like you would have to have um you would have to have like some features, some protein sequences that's real similar to a point to where a slight modification like could a slight modification could build those features like you know but it would already have to be built into it. But you just can't just like you can't just add things on. Like you can't add like a like a third arm, okay, onto your body, because that third arm ain't gonna have no type of it ain't gonna have no skeletal or muscular support or no to be able to do anything. It's gonna be dangling. You see what I'm saying? So you would have to have those regulatory networks in place. And then and again, that would be rapid evolution. I I don't think rapid evolution is evolution. I think rapid evolution is a built-in mechanism that's designed to adapt to the environment. Okay, and you got regulatory networks already in place. You just can't just build stuff without the regulatory networks in place already. You just can't do it because otherwise it'd be useless. And then evolution will probably take care of and do what it's supposed to do and rid it from the population.
Yeah, I mean that's one limitation of evolution, where that's why we don't see humans with third arms.
We don't see humans with, yeah, of course, yeah, yeah, because they get weeded out, right? But the thing about it is, what you want is you
Well, no,
want to get.
because there are too many regulatory steps. Um, whereas you can evolve new vertebrae. Like there's like the bats and the pigs uh, evolve new vertebrae,
No,
new
that's just
ribs.
that's lengthening and shortening. Well, I
Well,
mean,
they
that's kind
they
of
actually
the
have
pig
more.
thing, yeah, right. The pig thing was kind of like I haven't really seen that one before. That could be a fluke. It could be. I'm not sure what that was right there. That's the first time I've seen that one. So I can't really speak on that one. But it is a rib cage. It's not it's not a wing.
Yeah,
So
but
but the thing about
but the
the thing.
length of the bones that are already there is highly variable.
Okay, I have no problem with that. I'm an evolutionist, if that's the case. I got no problem with that. I don't even have a problem with the gliders and stuff like that. You could have those. What you got is you just got skin folds. You got additional skin. You got regulation that's allowing that skin to grow longer. Okay, I got no problem with that. I got no problem with the that lizard that can glide. But what you don't have is you don't have no sternum or no muscle attachment that attach to the middle right there that allow it to fly. See, you don't have that. And then you don't have the genes and the regulation and the nerves to add that. You got the gliding, but you got additional skin. True. you know Same as that lizard. Yeah, you got that additional skin. It's a beautiful specimen, you know what I mean? But I don't know how, that's probably not nothing that's very difficult to achieve.
So
But when you can,
with flying squirrels, are you do you think that they're
they're
related
not,
to
they're
regular
gliding
squirrels?
squirrels. Yeah, they probably are. They're gliding squirrels. They're not flying, they're gliding. Yeah, I would say that
Yeah, but
that
so do you?
you know
Is that the limit? Is there if they evolved stronger pectoral muscles and uh,
if
larger
they
shoulder
evolve.
blades like bats have and longer fingers?
I mean, you think that's going to turn them into bats? What is it going to turn them into?
Well,
I
would it
think,
be
I
able to
think.
give them powered flight like bats?
Well, I mean, hypothetically, this I don't. I think it's more to that because here's the thing about it. Here's the thing: when you got flight, right? Then you got a bird brain. You got an avian brain, right? And then you got avian brain. Then you got a GPS system, right? So do they evolve a GPS system too? See, all this stuff is
Well,
pointing
we're talking
to
about
something.
bat-like wings.
It can evolve. Well, the bat like wings is more like a skin um versus the fur.
Yeah, I'm just talking
That's
about
more of
is it possible for a flying squirrel to evolve or adapt stronger wings? Because they already have one elongated
if they
finger.
had if they had I mean I guess if they had that in their gene pool that they could do that, or it could be the fact that they could try to do that and then chaperone protein be like, no, I don't think so.
But they already have in
Cha-
their gene pool fingers and skin.
so can they get a mutation, make them longer fingers?
Yeah.
I mean, it's hypothetically possible.
And then I don't know if they have shoulder blades that are strong enough, but couldn't isn't that possible for them to get larger shoulder blades and larger shoulder muscles basically for flapping harder?
I mean that's more reasonable than them evolving a GPS system. I mean, I don't know. I guess are you saying that they could have evolved into bats or something?
A bat like wing.
I don't know. I mean, I don't think they would got a bat like wing. I don't think they will be.
Or do you think
I
it's
just
possible that bats came from a gliding animal that just got better?
I doubt it. Nah, I don't think so. I don't think so. I don't think they even look close enough together. I doubt it. I don't know where bats came from. Bats, you know,
Because the
I don't think
oldest
I don't think they
bats
came from anything.
have
I don't think they
much
came from
shorter
anything.
fingers.
I think they was just made. No, it could just be. See, I don't know if I agree with like one being older or younger. I think that that older is to tell the story. Where okay, again, if those bats were found in um um sedimentary rocks, that means that it was a big flood and mixed them around. I don't agree with the geologic column that you find this here and you find that there, then all of a sudden this is telling that beautiful story. I feel like if you find a bat fossil, they're gonna ask you where you found it at. You're gonna say, "Well, I found it here." And they're gonna say, "Well, we're gonna assign it to well, this is probably whatever," and they'll assign it to whatever place that tells the story. I don't think that there's a lot of space in between them anyway. They're gonna get mixed in together. If you had a flood, if those bats were found, that means they were buried rapidly, either in a
If
flood or a volcano.
if they were
I
that
mean,
mixed, then we wouldn't be able to predict what kind of fossils are going to be in which strata.
I don't think that there's a lot of prediction going on. I just think that you got floods, and then when you get floods, creatures get buried together,
But
kind of.
there's a definite pattern to which animals are found in which strata.
I think they got buried together. I think they just got buried. They were in this spot and they got buried right there because it was a flood. They were hanging out together and they got buried, whether it was a worldwide flood or a local flood. You know, I mean, because even if it was a flood, right, and you had these rocks, the flood is going to be mixing them up anyway. The flood is going to mix. It's going to come into the land big enough, and it's going to mix that dirt.
Oh,
It's going to
sure,
lift that
it could
up.
mix things that are like contemporaneous with it.
Yeah, I mean, it's hard. It's really hard for you to try to prove that through the fossil records, because the thing about it is this here. Even the paleontologists admit that the fossil record is scant. It's in bad shape.
Well, really,
You know,
the proof would be in how well it's able to predict things again.
if if you had a worldwide flood and people lost all their knowledge, and only some people didn't have knowledge of this and knowledge of that, and then they started digging up dog fossils. They could do the same damn thing with dogs. They
But
could be like, "Hey,
it wouldn't.
evolved from that dog."
It's not just being surprised every time. There's hold on one second. What? Sorry.
Yeah,
Um, what were we saying? It's
not being surprised all the time.
yeah. There's an element of sometimes they know what's going to be in there.
Yeah, because they can. I mean, it's like those predictions are so scant. We're gonna find. Well, we know we see this creature got this thing, that one. So we probably gonna find something kind of like this, you know. And like I said, the ones that don't get found, the predictions they don't talk about.
But there's one method that's more accurate than any other method, and that's
We
evolution.
It depends on. I don't agree with that. I think it's more accurate when we say, what, we got an intelligent design that's beyond our realm of understanding. What we'll find is we'll find the cells is going to be so complex. We're going to find we're going to find You know, um, that dogs is going to produce dogs, cats going to produce cats. Okay, we're going to find complexity in the cell. We're going to find that it's order in the universe. You know what I'm saying? We're going to find that all these creatures are going to be buried in this worldwide flood. Man, look. I got these on my TV. They showing these Google pictures. If you just leave your TV on, this is a Sony, and you don't do anything, these pictures come up. Man, I got the most beautiful picture of the Grand Canyon, and then the separation of the different rocks and everything. It just showed me so many beautiful pictures. You ever just leave your TV on, just not look at it, and we just let it go through the pictures? You ever do that?
Oh yeah,
Man, these pictures is beautiful. All of them. It's beautiful.
yeah.
Hummingbirds. These pictures is. I'm a photographer too. That's the reason why I got an appreciation for that. But yeah, like the same thing with the dogs. The bat. You just got a lot of different bats. You know, there's a lot of variation, but you don't have an ancestor. And to me, that's really not a big deal to me.
Well, there are
You know,
we we should expect gaps, or else we'd stop looking
yeah,
for
I get it.
fossils.
I get it.
The
But
the gaps shrink all the time, but
necessarily, they just put something in it that don't belong there. That's like that's like if you looking for your stopper for your sink, and you can't find it, and you go ghetto, and you go put a torn up rag in there. You know what I'm saying?
there's a
You know,
pattern to the natural world, and so whatever theory is best able to predict it is what's scientific. That like the old philosophers used to try and explain natural phenomena, and that's when they were like, well, you get sick if you like ingest a demon or something, and to them the story fit, but
but
you
that's
weren't
some
actually able to predict like which places actually have the bad air or whatnot.
right. Yeah,
The cell theory was able to predict much better the behavior of the natural world, and so that's more scientific.
well, yeah. I mean that's cool too. But what about the fact is that when they were like God was telling you to wash your hands and this and that and certain stuff, it was certain things in the Bible that like,
Sure, I
you
mean
know,
you could have a competing hypothesis, like God tells you to wash your hands versus
but
germ
what
theory tells
about,
you to wash your hands. But
right? But what about God? But what about God saying, talking about the fountains of the great deep up under the water? There were no um what do you call it, deep sea divers that knew nothing about the fountains of the great deep, underwater caverns beneath the sea. They didn't know nothing about that stuff. And the Bible actually predicted that. The Bible predicted that, the creation, the beginning of the universe, you
that there
know.
would be underground caverns.
Yeah. You think that the Bible talks about underground caverns beneath the sea, springs, and then the fountains of the great deep. He talked about the when Noah's flood, the fountains of the great deep opened up, and water shot about the fountains of the great deep. That's just like Noah's flood. That's just and it ripped around the earth. That's just like the Atlantic Ridge, the Mid Atlantic Ridge. This whole splitting like a baseball all across the planet, everywhere. It was where the water shot up from there. That's in Noah's flood. The Bible predicted that.
I'm not sure
I could
you
find
could
that.
count that, but it's pretty vague. Um,
Well, I mean, you got the a splitting of the earth all the way across the earth,
but
you
that's
know,
that's the only one I've ever heard. So I
and you
could
got
I could
water.
give you that one as a
Okay,
legitimate
what about
prediction, but what else is the Bible
He
useful
talked about
for in the
the
natural world.
earth. He talked about the earth. Nothing holds the earth holds up the moon or something like that. No, no, the earth is it stands up on nothing or something like that. The world stands up on nothing. Um, I forgot something like that.
Well, and oftentimes the Bible is making the same prediction as just the natural sciences.
And it said the
So
earth
that
is a too. It said the earth is a
I'm sure
sphere
the
too.
Bible says the sun will come up tomorrow too.
Well, yeah, but it's yeah. Well, yeah, but
So
I'm trying to figure out.
it's got to
Man,
be like a novel prediction.
you got any dogs or cats, man?
Yeah,
Man, I got
I
three
got a.
dogs in my bed and a cat on my damn chest right now. They won't give me no damn room.
I
God,
can
what do you got?
just one dog.
You want
So
you
you're
need to take
lucky.
a couple of these.
You got four little fur babies.
Four, yep, and a cat that's on me right now. They won't give me no. Come on, kitty. I gotta have some room now. Come on now. Gosh, gosh. What kind of dog you got?
She's a mix, so she's 1/3 Chihuahua, 1/3 Yorkie, and 1/3 poodle.
Wow.
Yeah,
Wait a minute. Poodle, how big is it?
she's like 11 pounds.
Okay, the poodle part make it look a little, well, make it a little bit bigger, don't it?
Well, poodles, like my parents and growing up, we've always had like small poodles, little lapdog
Right.
poodles.
Uh-huh.
Um, so her parents were a poodle Yorkie and a poodle Chihuahua.
Wow.
Yeah,
You never post your dog pictures online or anything?
I do. She's at the end of all my videos.
Oh, I gotta look at one of your videos and see.
Yeah.
I got a King Charles. You know what a King Charles is?
Uh-uh.
King Charles Cavalier.
I've heard it before, but I can't picture it.
They look okay. Well, most people look well. She and then the one is a part King Charles and a Cocker Spaniel. The Lady and the Tramp. You ever see the dog, the Lady and the Tramp, the cartoon?
Yeah.
That she's that. That's what a King Charles is.
Okay.
Then I got this one is a mix. I don't know what he's in. He's like three different things. I don't know what it is. When they sold it to us, they lied.
Yeah.
So can't tell.
Well, I like
But
mutts better anyway.
well, they live longer
Yeah.
for one thing because they got more genes. See, it's when you start separating them, and when you get less genes is when they get less healthy. That's why I say
Well,
evolution is
they got more diverse genes.
right. And then when you isolate them, you get less material, right?
Uh, it's not that it's less. It's that there's less variety, and
Well,
so
that and if they get mutations, they get any mutations. That means the mutations, they get
so
fixing the population much easier.
so by ancestry, my dog is actually half poodle, but genetically she's only a third poodle because there's only a certain amount of slots, like the heterozygosity thing, for
Right.
genes, and so most of those are overlapping between her two parents. Their poodle
I'm
genes
not sure.
overlap.
I'm not sure I agree with that principle. Why can't why can't there be extra variance? I mean, why? Okay, okay. Well, that's what you're saying. You're right because you got. I see what you. But what I'm saying is, okay, so you got two chromosomes, right? I'm sorry. You got the genes for your father, the genes for your mother,
Hmm.
right? And you saying you got one each for either one, right?
Yeah, and sometimes they're the same. Well, most of the time
Okay.
they're the
Okay.
same
So why can't you have two genes per two? Two from your father, two from your mother.
because you only
One
get
gene.
one from each.
How do you know that? But what I'm saying is, why can't you have Why can't you have why couldn't why couldn't they have started with two and then they only got one now?
They do.
Why
So
can't it be
they can
front loaded?
have two of the same copy or two different copies, but you can only inherit one.
Two of the same cop. Wait a minute. Wait a minute. Okay, we talk about one individual. Let's think about a father.
Uh huh.
Why can't like early like Moses or something or Adam? Why couldn't Adam have had two copies of uh genes? He could have had a copy of blue and a copy of brown genes in his DNA, and Eve had a green and a what else is what other colors is it?
Well, under that he
Uh
would have like two copies of brown and two copies of blue.
yeah, why couldn't he have
Right.
had that?
Um,
What stops
he
that from happening?
he could, but that's not what we see.
Okay, true. Okay, so when we have mutations, we lose information. How do
So,
you know?
well, yeah, that means that
Have anybody ever searched for that? Though?
all humans have lost that gene, which is
Okay,
like
so
really unlikely.
I see what you're saying, but what I'm saying, right? That's a beautiful picture right there. This is a picture of this road. The perspective is just so phenomenal. It's like a, it's kind of hard to describe. It's just the way. Um, are you familiar with a feature called Rule of Thirds?
Yeah,
Okay,
the
so
golden
it's doing
ratio.
yeah. Well, this is not necessarily a golden ratio because the golden ratio kind of if it was more material inside the picture, it would look at that. But the rule of thirds is how you have the sky like one third, and then you got the ground is taking up one third, and then you got this green this yellow streak going across the lines of the road is leading the eye is leading the eye actually is leading the eye toward the picture,
Yeah,
right, toward the front, and then you have why that's gone. Now this one is beautiful. It's a leaf with a big bead of water, and then you got the little droplets, and then you got the bokeh. You got it's a pretty big aperture where you have only part of it in focus, and then as it falls out of it blur. It's you know what bokeh means in photography.
Boca?
Yeah,
No.
it basically so if you ever want to do a good picture of photography of you, okay, or your girl or whatever, you will always have your picture, your part real sharp, and the background will be blurred. And this will put the focus on you, and
Hmm.
the background will be it will you will be the principal, and the background will be the background. So it wouldn't be sharp. Because if everything in the picture was sharp, then where would the eye travel?
Hmm.
See, you want the eye to travel to the subject. So that's what this is right here. But anyway, I'm getting off topic.
Yeah, I need to
Um,
get better with that for like making thumbnails and stuff.
Well, if you want to make real art, what kind of phone you got?
Galaxy S22 or something.
Okay, yeah. I don't know if you can put your camera on portrait. You use your phone to take your pictures.
Yeah.
Okay, it may be a portrait mode on there. It may be an expert mode. I think I got a 21. They don't have it. But it may be an expert mode on there. Actually, you know, who had a good camera was the Redmi that Chinese one Redmi something.
Mm-mm.
Um, yeah, they
Oh,
had some
maybe I
damn.
know it. Oh, yeah. I think I've heard of that.
It's Ying Chang or something like that.
Yeah.
They really had damn good better camera than the one I got right here, and that was a Redmi 7. It's like an 11. Xiaomi is what it is. Xiaomi. So I don't know. I'm so sick of Samsung crippling my damn phone. All these updates I get, all they do is cripple it. All they doing is crippling it. My Note 8 completely crippled. It does the stupidest stuff now because they want you to buy another one. I'm going Apple next time.
Yeah.
I
Well,
can't take Samsung.
I started with the iPhone and switched over to Samsung.
Well, I thought iPhone was better though. It ain't better. You don't like it better?
iPhone?
Yeah.
Nah.
Which iPhone did you have? The
Oh, that
last one
was
you had.
like 10 years ago.
Okay, well that's yeah. You can't even go off of that no more.
Yeah.
Yeah, you can't.
I just generally don't like Apple stuff.
I like
Like
my iPad. I
back
love
back
my
when
iPad.
back when iPods were still a thing, just the iPod. I never had an iPod. I had like Creative. That was the company. Microsoft tried to do the Zune. I never had a Zune, but I had like those off-brand MP3s because I just didn't like Apple.
But I ain't familiar with those ones.
Yeah.
So let me ask you a question. Who else do you have in your your video, not your videos, but your like what we're doing right now. Do you have other people in here, like atheists and this and that, evolutionists, whatever?
Yeah.
All right, because I do want to get involved with like other people. You know what I'm saying? Somebody else, like
Yeah.
uh,
So
I want to do Ian Chan. I think I want to. I think I want to go. I think I want to talk with him, man, and see what he got to talk about because he's very negative. It
who?
seemed like that dude Ian Chan or whatever. He
Oh,
debated
Ian.
Ian. He
Yeah.
debated Ken Hovind, and he was very disrespectful, man. But I got to admit, he was a little bit funny though.
Yeah.
But he was almost racist a little bit, you know. But
Kent
he was,
was.
huh? No,
Kent
no, no,
was.
no, no. The other guy, the Chan or whatever his name is, he was saying some hillbilly stuff about. He was saying some stuff about Ken Hovind. Ken Hovind took it, you know what I'm saying, but he was being very disrespectful, man. You don't know what I'm talking about? Didn't you watch that debate?
Yeah. Yep.
You don't remember him saying some stuff about Ken Hovind being a hillbilly.
I don't remember that. I remember Kent not understanding his accent
Oh yeah, that
because he's
was yeah.
Australian.
Oh, I thought
But
he was a
he went in there like his only goal was to make fun of Kent.
yeah, that's what it was. I can tell.
Yeah.
But I catch him in the chat a lot, but I never really see him
Well,
like talk to anybody.
he'll probably watch this. But yeah,
Right.
my other channel, Debate Cafe, is we're doing like open mic stuff for group discussions and stuff.
Yeah, put me in on one of those.
All right.
You know what I'm saying? I just gotta be ready. Cause like you don't be checking your what's your names good though. Cause I was in there, honestly, I was up in there for about I couldn't talk the first time when you actually called because I was talking to I was getting my 401k diversified in an IRA, and that was big. I had to try to bleeding on one account, and I was making money on the other one. I was trying to get that money transferred over. I got tired of bleeding like that. You know what I'm saying? So
Yeah.
I was on the phone with them. You had called in, then I had called back about what 5 minutes later. And all I'm hearing was stuff you must have been in a different room or something.
Yeah. I just moved out to the living room, and then
Oh, you went to the
I
bar.
missed you coming into the call.
Oh, you was on another room or something.
Yeah, I just left the call up, and then
Right.
yeah, then I realized
Now,
you emailed me, and I came right over.
right. But I've got so real quick before I get into that one. I tried to get back to your email. I can't even pull up your emails.
Huh.
When I try to pull up your emails, only thing come up when I put your name is my responses. Yours don't show up. It's kind of weird.
Huh.
Does that make sense at all? It could be something real simple I'm doing, but I don't know what it is.
Yeah, I don't know.
Well, anyway, what's the other one? The other one. When do you go on the other one? Do you ever do that like early, like
It's that's usually later.
oh late at night?
Yeah,
I can probably do that, but I just can't do it in this room because if I do it in this room, my girl will freak out. She go to bed extra early.
yeah.
So listen, I'm gonna get off here, but listen, when is the next time you gonna do the room with the that open mic thing?
Whenever. I mean, I could do tomorrow night or tomorrow during the day.
What's tomorrow night? What's tomorrow night? Tomorrow night, Friday.
I need to do it more. I've been slacking off a little bit.
During the day is a little bit better, but what time zone are you in?
Mountain time,
You in what city you live in?
Denver.
Okay, so I'm in Eastern time. I'm in Cleveland.
Okay.
So a good time to catch me is when I'm at work. But I just if I get a customer come in the store, then I gotta hang up and then come back. 'Cause I cannot be definitely can't be doing why. But if I
Yeah.
got no customer in the store, that would be fun though. Actually talking to some more atheists or evolutionists or whatever, you
Yeah.
know. And I would rather be civil about it. You know what I'm saying? I can get ratchet, but I would rather not have to do that. You know
Yeah.
what I'm saying?
Yeah.
But I know it cuts both ways. So
Yeah. Well, I'll be there moderating to keep it like not too crazy. So yeah.
okay, well, hit me up tomorrow, like after like 11 o'clock, or yeah, probably after 11 o'clock. Let me get my work done first. Get some work done first before you know what I'm saying. And then if you do that, we'll see what's good.
Yeah, we
We-
had
Uh,
a good showing last time I did it. I was testing out my streaming, so there was like a huge delay in what was live and
mhm.
what was actually going on. But I
That could be a
figured,
problem because that got people
yeah.
talking over each other.
Well, I figured that out. I was like streaming a game that was like really messing it up. And I'm doing it right now too. So
Well, only thing I don't like though is I don't like to not being able to use my damn Bluetooth. Oh, you
yeah.
know what? I got my iPad though. Would the iPad would it work with Bluetooth better or not?
Uh, I would guess yeah, but usually
Okay,
the iPad, usually the pads run off the same software as the phones.
hmm. I
I'm
tell you
not
what.
sure.
Hold on. Let me see. Let me try to.
But yeah, we had a
Let me
good
see.
showing, but that was at night. I'm not sure how well daytime will
Oh,
do, but a lot
say
of other
not.
people stream during the day. Like the Answers in Atheism are on, like for me, usually 2, 3 o'clock.
Let me see. I'm
I'm
trying to
always
see
like, do
if
you
it's
guys have jobs? You're just streaming all day.
right. Let me see if I can put Skype on this put Skype on this iPad and see how that one work. Um,
Yeah, well, we
let me
can we
see.
can go test that, but if yeah, if we want to wrap this one up, I'll just stop recording and then I'll help you test the iPad.
Right. Well, let me see if I can. Oh, it says Skype for iPad. And then I gotta remember my only problem is I gotta remember my damn my password.